Hello friends, let's have a look at today's daily challenge problem. The case lexicographical string of all happy strings of length n. In this video, we are going to explain how to address this problem by backtracking. First, I'm going to write a solution based on generating all the happy strings of given length, and then I'm going to take into consideration of the key. So here, the problem statement first defines what's a happy string. So for example, it consists of letters from this set A, B, C, and also two consecutive letters cannot be the same. So for example, those three are violating the second item. So here, given n and k, we want to find the case happy string if it exists. So example 1 and example 2 demonstrate this part, right? It's very easy. When n equals 1, so these are the three length 1 happy string. So k equals 3, you need to return C. Any k greater than 3, you should return empty. So in example 3, so there are 12 different happy strings. So we are going to return the nonce, that is CAB, cap. So actually in our first solution, we are going to generate all the happy strings. So here the constraints are the following. First, n is bounded above by 10. So this essentially restricts the size of the problem. So k is given in this range. So with that said, let me go to the coding part. So here, I guess if you look at this two items, actually these two items on their own, they are the problem requirements. Actually, you will see it will corresponding to some coding format in our solution. First, I'm going to write a solution. Let's call it backtrack. So here, I want to initialize a result variable. So this list will hold all the happy strings. So I guess also in lexicographical order. So then what I'm going to write is a recursive DFS. So we have a string, let's call it happy string anyway. So we want to generate all the happy strings of the given length n. Let's first ignore the key, right? So first, if I equals n, because the length is n, so the largest index will be n minus 1. So if I is auto bound, so meaning that we finished building a happy string. So we are going to append the current state of happy string to the result. So notice that this result variable is mutable. So I don't need to write non-local result here. But if you write this, that's fine, but not necessary. Also, Python is passed by reference. So here we are actually passing the current state of the happy string. So this is the one thing. So once we have this, we just return. And otherwise, so we need to build that. So for character in A, B, C, notice the order here. Always I first use A. If I cannot use A, then I use B. If I cannot use B, I use C. So this will give us the lexicographical order. So now let's check the, so this also embodies the first bullet item, right? So now let's also look at the second bullet item. So then we want to check if happy string is not empty and the happy string, the last character, if it were equal to the current character. So in other words, we cannot add to the end the current character to happy string. So we just continue. After this if check, what do we do? So actually what we do is backtrack. So from the next index. But now I'm using the current character. So I'm going to do happy string plus the character. So that's it actually. So that's the overall function that builds all the happy strings of length n. So now we can call this backtrack function. So starting from index 0 and then from an empty string. So if you call this function, you can think of it as a worker. It's going to modify the result and add the happy strings to the result list. So we can print out those. Has no attribute get happy string. So here I write v1. Let me modify that. Yeah, so you can see in the first example we get ABC, right? And in the second example we also get ABC. Well, in the third one we get 12, right? 12 happy strings in lexicographical order. So for the return, actually it's rather straightforward. So what we want to return is result k minus 1, right? If length result is greater than or equal to k, at least k happy strings. Otherwise, we get a empty string. That's the requirement for this problem. Now let's submit that. Yeah, it passes the case, but it's a little bit slow because we generate all the happy strings, but it's not necessary. We just need to think of the case one in the lexicographic order, right? So in this case, I can think of one thing. So we can first have a count variable. So originally 0, right? So each time, if I get this one, if the count is incremented by 1, so right. So what we want to do is like this. Maybe this might be not good. Let me rewrote, because that's this will destroy the integrity of the code. Let me submit again to make it correct. And then I'm going to copy this one. I'm going to write another version of the solution, so taking into consideration of the key. So let me call this one version v1. And what I'm going to do, I don't need to generate all those, so I just delete the result. So I'm introducing a counting variable, but this time, because the counting is counting how many happy strings we have generated, because this guy is immutable. So if we want to modify the value, we need to make it non-local. So then for this case, so we don't need to modify the result, right? So if I equals n, so we are going to increment the count variable by 1, meaning that we generated a happy string again, right? So then I want to do if count equals k. So we're going to return the happy string directly. So otherwise, we just return. In other words, return nothing. And then we continue this procedure, right? So this is the same due to the second bullet item. But now what we want to do is this. If result, so if there is something returned, meaning that we built the case happy string, so we just return the result. Otherwise, still we return nothing, right? So then what we want to do is we call like this. So we have a result variable, but this time it's a string or empty or null. So what we want to return is result if result is not null. Otherwise, we return empty. So this one is a slightly improvement of the first version. But I guess personally, the first version is easier to digest, right? Let me run it. Result where it's not associated with a value. Let's see here. If let's see what we, I guess, do backtracking. I call this one is result, right? And then if result, we are going to return that. So it passes the 3 test cases. Now let's look at the generic case. Yeah, it passes all the cases. I guess that's basically about it for this problem. So here there are several things to be emphasized. First, let's look at the coding format, no matter in version v1 or version v2. So this bullet point actually is demonstrated here, right? So this take into consideration of lexicographic order due to the A and B, C order. And also the second bullet item is given here by the if condition, right? So that's actually why we see at the very beginning. So the requirements also has something to do with the coding format, right? That's actually for sure also. So that's one comment. Another comment is that you need to understand that for the language Python, it's passing by reference, right? So you can see here, this guy is mutable, so we don't need to use non-local keyword. And here, count is immutable, so here we need to use non-local keywords. So I guess this video demonstrates enough information. I will stop here. Thank you for watching.